Assalamu alaikum friends, this is Sayyida OMAMA SHAH and today we will be studying the eye physiology. I will teach the physiology of eye in such a way that your basic concept regarding eye will be cleared and you will have no doubt regarding this topic. So without delay, let's start our today's topic. So friends, here you can see the structure of eye. This is the candle from which the light is passing inside the eye. It passes through the cornea and it bends, and again it passes through the lens and bends, converge at a point called the focal point. This focal point is on the retina. By having a focal point on the retina, the eye is able to see the incoming light. The distance between the focal point and the lens is called as the focal length, right? And we're going to discuss the optics of vision in detail in this video, so let's move on. Now first we are going to discuss some basic terms regarding optic of vision, and in that we have refraction. Now what a refraction basically is, the refraction is the bending of light rays when it passes through an angulated interface. The angulated interface is an interface that is at certain angle. The interface is basically the surface between two media. Now here you can see this is the air and this is the glass. So this surface is between these two media, so this surface is called as the interface. Now if this interface is at certain angle with respect to the incoming light, then the light will bend, and this bending of light will be called as refraction. Now if there is if there is no angle, you can say, or if the wavefront is perpendicular to the incoming light, then the light rays will not bend, rather it will move straight, as you can see here in the first case. Only what will happen, the wavelength will decrease. Here you can see this is a compression. The wavelength is the distance between two compressions. So this wavelength is greater as compared to this wavelength. This is compression. You can see wavelength as distance between two compression or diffraction. If here you can take this as compression, two compression, so this distance is called as the wavelength. And if you can see over here, this wavelength is greater as compared to this wavelength. This is shorter. So you can see that only there is difference of wavelength, and ultimately there will be a reduction in the velocity. So if the angle is if there is no angle, or the medium is not an oblique or at certain angle to the incoming light, then the light will not bend, right? Then there will be no refraction. But if the glass or any other medium is at certain angle, then the light rays will bend, and this bending of light will be then called as a refraction. Right now this refraction depends upon two factors. One is the difference in the refractive index, and one is the angulation. The angulation we discussed. Now coming towards the refractive index. Now what a refractive index is, now coming towards that. So you can see over here the ratio of velocity of light in air to that in medium. Now if you can take this as air and take this as glass, so the speed of light in air is 300,000 km per second, while that in glass is 200,000 km per second. So what you have to do, you have to divide the 300,000 km per second by the 200,000 km per second, and you can get the 1.5 refractive index. So that is basically the refractive index. If you divide the velocity of light in air to that in any other medium, so the value that you will get will be the refractive index. The air refractive index is 1. And how can I say it? Because I can say it in a sense that the light is coming from the sun, and on the way it passes through the vacuum. So the light travels in the vacuum is 300,000 km per second, and the same is that in the air. So divide 300,000 km by same 300,000 km, so we get the value 1. So the I can say that air has 1 refractive index, while glass is 1.5. Now the greater the refractive index, so the greater will be the refraction, right? If I can say that if light is coming from and passing through the vacuum and coming inside the space, so there will be no refraction. But here when a light is passing through the glass, and the glass is the other medium, and it has greater refractive index such that 1.5, so it slightly bent. So morely I can say that, or I can conclude that refraction depends upon two factors. One is the angulation. If the medium is placed in at certain angle, then the refraction will occur, otherwise there will be no refraction. Or it also depends upon the refractive index. Greater the refractive index, greater will be the refraction. So this was a basic concept regarding the refraction. Now we are going to study more further about the optics of vision in detail. So let's move on. Now let's study what a convex lens is. Here you can see the figure. This is a convex lens. When a light rays passes through this convex lens, and here you can see this is at certain angle, right? So it converge. The converging power of this lens is called as refractive power. The greater converging power, the greater refractive power, and that refractive power we measured in diopter. We will study this more in detail in the next slides. Now when the light rays are converged, it converge at a certain point, and that point is called as the focal point. Now in order to see some object, this focal point must be on the retina, right? If it is away or in front of the retina, then there will be disorders. We will discuss that also. The distance between the lens and the focal point is called as the focal length. Now the greater the focal length, the lesser will be the diopter. We discussed that the greater the converging power. If this convex lens has greater converging power, it means that there will be high refractive power, so the focal point will be nearer to the lens, right? So focal length will be ultimately lesser. Now here you can see a concave lens. This is a concave lens, and a concave lens diverge the light rays. So this is a basic about the concave lens, and these convex lens and concave lens are used in disorders such that hyperopia and myopia. In different cases we will use different lenses, and we are going to discuss that in further slides. So let's move onwards. Now coming towards the refractive power, I told you refractive power in short in the previous slides. Here we are going to discuss this refractive power in detail. So the ability of lens to bend light rays is basically called as the refractive power. If the lens converge the light or bend the light more, it means that the refractive power will be more, right? And the focal point in that case will be nearer to the lens. So the greater converging power, the greater will be the refractive power, and the nearer will be the focal point towards the lens. And this refractive power is measured in terms of diopter. Now let's see what a diopter is. Here you can see this is a lens. These are the lenses, right? This is somewhat a round in shape, and this is somewhat more slightly narrower, right? Now if the convex lens is in a more in a balloon shape, or you can say more in a spherical shape, then their ability to converge will be more, right? And the focal point will be nearer the lens. This has greater refractive power, greater converging ability, and lesser focal length. So you can say that the diopter is inversely proportional to the focal length, right? Here you can see the focal length is somewhat greater as compared to this one. So this has lesser diopter, such that 2 diopter, and it has lesser converging ability or bending ability, you can say, and ultimately lesser refractive power, you can say. And here you can see this is the focal length, and this is 1 meter, right? So 1 meter divided by 1, so we get 1 diopter. So this is the 1 diopter is the minimum diopter, you can see. So this was all about the basic concept. We will divide the 1 meter by 1 focal length, and then we will get the diopter. 1 meter divided by 1 focal length, if the focal length is 1 meter, right? So we will get 1 diopter. If it is somewhat nearer, here you can see it is half of this, so 1 divided by somewhat 0.5, then we will get 2, and here in this case we get 10 diopters. Now the topic that we are going to discuss is very much important and essential, and that is the accommodation. Now what an accommodation is. The accommodation is basically the adjustment of the lens in order to see objects that are at various distances. And the accommodation may be of positive accommodation or it may be negative accommodation. These are the two types of accommodation depending upon the ciliary muscle. If it is in contracted state, so then it will be called as positive accommodation, but if it is in relaxed state, then it will be called as the negative accommodation. Here you can see this is the suspensory ligament, this is the sense, this is the lens, and these are the two fibers of the ciliary muscles. One is the meridional fibers and the other is the circular fibers. These two are the fibers of the ciliary muscles. Now if they both contract, what will happen, they will relax this suspensory ligament. Now if it is relaxed, then it will be more spherical in shape and it will converge more, or you can say bend more, or it will have a refractive power more, right? So this positive accommodation is for nearer objects. If something is nearer to the eye, what will happen, this ciliary muscle will contract and it will relax the suspensory ligament. Ultimately it will be more spherical in shape, it will have more converging power or ability, and the focal point will be on the retina, right? But if the object is placed far from the eye or it is at a longer distance, the opposite will be done. What will happen, the ciliary muscle will relax, right? When the ciliary muscles relaxes, it will contract the suspensory ligament and ultimately it will be less spherical in shape. So when it is less spherical, it will then have less refractive power or have low bending ability, and the focal point will again be on the retina. Here you can see in this figure, if it is less spherical, then there will be longer focal length and the lesser converging ability or bending ability or refractive power, you can see. But if it is more spherical in shape, so it will converge more, bend more, and will have a focal point nearer the lens or on the retina. So this was basics about the accommodation. Now if there is loss of the ability of lens to accommodate, then what will happen, this disorder is called as the presbyopia, right? So the presbyopia is basically the loss of accommodation. This was all about the basics. Now we are going to discuss more the disorders and further in the optics of vision. Now we are going to discuss the errors of refraction. Now if a person has normal vision, then his focal point will be on a retina, and then it is called as the ametropia, in which there is normal vision. But what if the focal point is crosses the retina, right, and it is behind the retina? Then the disorder is called as hyperopia, and it is called as the farsightedness. In farsightedness, the person is able to see far objects and he is unable to see nearer objects. Now why a person has hyperopia? It may be because of two reasons, right? Either his eyeball will be too short, right? If his eyeball is too short, then his lens and his retina will be nearer and his focal point will come behind the retina, right? Or it may be due to a refractive power, means he has less refractive power or bending ability. In that case also the focal point will come behind the retina, and that disorder we call as the hyperopia, right? And in this hyperopia, the person is able to see far objects and he is unable to see nearer objects because of the focal point coming behind the retina. Now here the other is the myopia, means nearsightedness. In this, the person is able to see near objects but he is unable to see far objects. It is also it may be also caused because of two reasons. Either the eyeball will be too large, right? if the eyeball is too large, what will happen, the retina and the lens, there will be more distance. So if the more distance, the focal point will come in front of the retina, or it may be also caused because of the greater refractive power. For example, if he has greater refractive power, it means that he has greater converging ability, so the light rays will converge in front of the retina because of its greater converging ability. This disorder is called as the myopia or nearsightedness. Now, how we will correct it? There must be some lenses used in order to correct this. Now, we know that the convex converge while the concave diverge. So here it needs to be converged more, right? So in case of hyperopia, we will use the convex lens. So the convex lens will do what? It will increase the refractive power, the bending ability, and in turn what will happen, the focal point will come on the retina and the disorder will be vanished, you can say temporary, by wearing the glasses of convex lenses. And here in myopia, what will happen, you have to use the lenses in glasses that must be concave, right? Because here it needs to be converged. So if concave lens is used, it will decrease the refractive power and this focal point will come on the retina, and this will also be you can say cured, right, by using a concave lens. So thank you friends for watching, and that's for all. Allah Hafiz.